All right, so here goes everything you ever wanted to know about heat, temperature, and thermal energy. You hopefully just watched a do know about the difference between, or I should say, how cold doesn't actually exist, that everything is about thermal energy. More thermal energy means something seems hotter, but it's all comparative. Cold is not actually a thing. So let's just go through the engage. If Jill is heating a large pot of water, and a small pot of water above a stove, she'll notice that the temperature in the small pot gets hotter quickly because there's less water than in the large pot. But what does that mean? What does it mean to say temperature is increasing or decreasing? What does temperature actually measure? And how does temperature relate to heat and thermal energy? So if Jill then adds a teaspoon of salt to the small pot of water, do you know how the salt will affect the boiling water? Pure water will boil at 100 degrees Celsius. That's why Celsius is a wonderful temperature scale. But salt water needs to be heated to a higher temperature for that boiling to happen. Therefore, adding salt will cause the water in the pot to take longer to boil. As any substance absorbs heat, the molecules that make up the substance gain energy and move further apart. So solids will start to melt. Liquids will start to evaporate. Dissolving salt in the water changes how the water molecules will actually interact with each other. More energy will then be needed to move the substance further apart. As you go through this lesson, learn about how heat affects substances on the molecular level. You'll learn more about the similarities and differences between heat and temperature, and next time you need to boil water, you will know exactly what's going on in that pot. If you wish to see any of these videos, you are free to come in here and check it out on your own. So, I'm not going to answer these. If you would like, you can. But I want to know what you think and what you know. So if we're going to go in and we're going to start to explore. Now it's not time for that. So, what's the relationship here? Thermal energy, temperature, and the motion of molecules in the substance. You take your hands, move them together. You feel them warm up. Sometimes you do it in the cold. Why does this happen? Well, we have to start to think about the molecules and the matter around us. They are constantly moving. And we'll remember from our states of matter that in a gas, the molecules are really spread out, bouncing around, freely moving through space, and they only come into contact when they hit each other. In a liquid, the molecules actually do touch. They slide around constantly and slip past each other all the time, but they can still move. In a solid, the atoms are sitting in place and they're kind of vibrating, right? But they don't actually move. They're actually locked in place. So just as objects around us moving have kinetic energy, which we haven't talked about, I hope you remember that from 5th grade, the temperature is a measure of the average kinetic energy of the molecules within a substance. Temperature tells you how much those molecules are moving around. When molecules move faster, they have more kinetic energy. Therefore, an object has a higher temperature if the molecules are moving faster. So when you rub your hands together, you make the molecules at the surface of your skin move faster, and this increase in the kinetic energy can increase the temperature. This model of particles in motion helps explain why matter changes state. Right? The faster or the higher the temperature gets, the more the molecules move, the more they collide into each other, escape their bonds, spread apart, move around. This explains why when you boil away water, it expands into a bigger gaseous space. Likewise, when you cool things down, you take the kinetic energy away, the molecules tend to start to sit in place and freeze and stop moving. This is why water freezes into solid ice as temperature goes down. So this is kinetic energy within molecules in an object. But there's also a potential energy here. All right. Potential energy is a result of forces that act between the atoms. So some energy is stored in between bonds in a block of ice, and you need to add kinetic energy to break those blocks. But the total energy of a thing, right, kinetic and potential, is known as thermal energy or internal energy. Temperature is only a measure of the energies molecules, not its actual thermal energy. Thermal energy depends on many different factors between the temperature, the state of matter, how many atoms, how big something is. All right. So let's break this down. A small glass of water may have a temperature of 38 degrees Celsius, which is roughly 80 degrees Fahrenheit. And a large lake may also have that same temperature. But the reality is the lake has more thermal energy because the lake has more water. What's that mean? Well, energy is the total matter of a substance. If you want to matter, the total energy of all the substance. So if I have more water at the same temperature, there is more energy. So this is your first question, but you have to answer that later. What's heat? How does it affect the molecules in a substance? Well, in everyday language, we might talk about heat as being a few different things. Sometimes heat refers to thermal energy of a substance. Or if you have a fever, you may say that you have heat in your body. Or we talk about increasing the temperature. We may heat up soup in a saucepan. But in science, we've got one way to talk about heat. Heat is the transfer of thermal energy from a warmer object to a cooler object. And heat is normally measured in calories, which is a word that you know from food. Heat transfer happens when there is a temperature difference between two objects. Heat will always move from hotter to colder. That's just what it does. When your hot dinner sits out on the table, it gets cold. The heat that was in that food, it goes into the air. But because there's more air than there was food, the air's not going to get as hot as your food. When the food is the same temperature as the air, you have a thermal equilibrium. There is no temperature flowing back and forth, right? Heat will never go cold to warm because it doesn't work that way. So, as you learned earlier, two objects can be at the same temperature and have very different amounts of thermal energy. The amount of heat needed to change the temperature of an object depends on how much thermal energy is in an object, right? It takes a lot more heat to heat up a lake than it does to heat up a cup of tea. It's just what it is. The amount of heat required to change the temperature of an object can also depend on the substance, right? It's going to be a lot harder to heat up an iron block than it's going to be to boil water. The phase of a substance, the amount of atoms in an object, and the environment. And questions about thermal equilibrium, but you have to answer that later. So, how does heat move? Well, heat moves through three ways: conduction, convection, and radiation. Conduction is what happens when molecules directly transfer energy. They actually have to be touching, much the way that pool balls hit each other and transfer energy. That is conduction. Generally, you don't get a lot of hitting in heat, though, right? What's an example of something like this? So, if you take your hands and your hands are warm, and you put them on the table and the table's cold, you can feel the heat conducting out of your hands and flowing into the table. Or, if somebody grabs your hand and their hands are real warm and you're just cold, you can feel the heat conducting in. All right. Convection is a little weirder. Convection is generally how liquids move and sometimes how air moves. If you've ever looked into boiling water, you see the water kind of curls up and around and curls up and around. This happens in gases too. This happens because as you heat liquids and gases, the density changes, right? Heat actually makes it less dense because it has more energy and they rise. Whereas as they get higher and higher, the energy will move out because they're hotter and disperse, and then they'll get cooler and they'll fall, and you get these really cool patterns. This is actually how the ocean and the atmosphere work, but we will talk more about that later. Radiation is the last process, right? And this is the crazy way. You cook food with this, right? Radiation is how heat transfers through electromagnetic waves. We haven't talked about that yet. We will. I just want you to know this, right? Microwaves cook with this. The sun gets its heat to the earth with this, right? All of this is about energy traveling. So this is another question you'll have to answer. Good luck.